Hello friends and welcome to another tutorial on Geeks for Geeks. In this video we are going to understand the program which helps us in finding the maximum path sum between two leaves of a binary tree. First, let us take an example. In this binary tree, the maximum path sum will be between nodes 3 and 10, which is 27. Now let us see the algorithm. Let us also have a sample tree to test our algorithm. We pass the root node and res variable to store the maximum path in the maxPathSum util function. As the root is not null, we check if root is a leaf node. Since it is false, we find maximum sum in left and right subtrees. Also, we find the maximum root to leaf sums in left and right subtrees and store them in ls and rs variables. So, first we pass the left child of 10, which is 8, using a call stack. Again, as root is not null and 8 is not a leaf node, we further pass the left child of 8, which is 3. So now root will point to 3. As root is not null, we check if root is a leaf node. Since node 3 does not have any children, it is a leaf node and we return root's data. So ls will be equal to 3 and we resume execution for node 8. Next, we pass the right child of 8, which is 5. So root will point to 5. Again, as root is not null, we check if root is a leaf node. Since node 5 does not have any children, it is a leaf node and hence we return root's data. So rs will be equal to 5 and we finish execution for node 5. Now we check if root has both left and right children. As node 8 has both left and right children, we update res. So res will be equal to ls plus rs plus root's data. We return max of ls and rs plus root's data. So 5 plus 8 equal to 13 is returned and we finish execution for node 8. Execution for node 10 is resumed and now we pass the right child of 10, which is 2. So root will point to 2. As root is not null, we check if root is a leaf node. As 2 is a leaf node, we return 2. Execution for node 10 is resumed and now we check if root has both left and right children. Since it is true for node 10, we update res. Since previous res was 16 and ls plus rs plus root's data is 25, so res will be modified to 25. We finish execution for this program and the maximum path sum is 24 for this binary tree. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.